In this video, we're going to have a look at some examples of using trig ratios when we're dealing with angles of elevation or depression. So first we need to understand what is an angle of elevation. An angle of elevation is simply an angle made from taking a horizontal position and looking upwards, or elevating our eyes, for example. So let's pretend we are a person. So our horizontal would be from our eyes, and when we're elevating our eyes, when we're looking up, perhaps to a plane in the sky, this is our angle of elevation. However, imagine that we are a worm on the ground. The horizontal would be directly on the ground, and its angle of elevation would be when it is looking upwards and is elevating its eyes. So it's from a horizontal looking up. Whereas an angle of depression is when we are taking a point from a horizontal and looking down. We are depressing our eyes. So imagine that we are a person on an aeroplane and we are looking down to the ground where the plane is going to land. We're going to depress our eyes, so the angle is from our horizontal in the sky looking down. So now that we know what an angle of elevation and depression are, let's put these into some examples. So in our first example, it says from a point on the ground, so I'm going to create a ground, 50 meters from the base of a vertical tower. So this is going to be my tower, and I'm 50 meters from the base of that tower. So let's put a dot. The angle of elevation of the top of the tower is 29 degrees. So I'm currently at this point on the ground and I am elevating my eyes to the top of the tower from the ground, and that's really important, and that is 29 degrees. So what I've got is a picture showing our ground, our tower, and how far we are elevating to the top of that tower. So what I want to do now is find the height of the tower. So I'm going to call the height h, and I can see I've created a right angle triangle, so I can use my trig ratios. Looking from the angle, I want to find the side opposite, and I know the side adjacent. So the tan of 29 degrees is h over 50, so I'm going to multiply by 50, place that in my calculator and get 27.72. So now I need to interpret my answer. So I can say the tower is 27.72 meters high. So in our second example, we have a bird sitting in a tree. It spots a worm on the ground at an angle of depression of 62 degrees. So before I read any further, I'm going to construct a diagram to help me. So I've got a ground, I've got a tree, I've got a bird in the tree, so I'm going to put B for bird, and a worm on the ground. The bird sees the worm at an angle of depression of 62 degrees. So where the bird is, we need to construct a horizontal for that bird. And that's that blue line I've dotted in. It is going to depress its eyes down to look at this worm. And that's 62 degrees down. So we can see that we've created a right angled triangle from here. And we can then continue to say if the bird is sitting 8.5 meters above the ground in the tree, how far is the worm from the base of the tree? So we want to find this distance here. So I'm going to call that distance D. So in this right angled triangle that I've created here, I haven't currently got an angle within that triangle. There's two angles I can find in this triangle. One of the easiest ones is to recognize that the ground and the horizontal that we've created here at the bird's horizontal line of sight are actually parallel to each other, which means the angle alternate to the 62 here is also 62. The other angle is I know that the tree and the bird's horizontal also makes 90 degrees, so I could also find this angle inside the triangle at the top being 28. So I can either look from an angle of 28 degrees in my right triangle or an angle of 62. I'm going to look from the angle of 62 because that's the value I've given. So I'm going to look, I know the opposite side of 8.5 and I want to find the adjacent side of D, the distance of the worm from the tree. So the tan of 62 is equal to opposite 8.5 over the adjacent, which is side D, which means D is going to be 8.5 divided by tan 62. So D is going to be 4.52. Again, if we used the angle 28, looking from there, I would still use opposite over adjacent. However, the opposite side would be D and the adjacent would be 8.5, and I still get the distance as 4.52. So let's write a solution. The worm is 4.52 meters from the base of the tree. So now I'd like you to have a look at the following question. We've got a man who's 1.8 meters tall. He can see a plane flying in the sky at an angle of elevation of 75 degrees. So I'd like you to work out the altitude of the plane, which is basically how high is the plane from the ground. So I'd like you to pause the video and then come back and check your solution. Okay, so let's take some information here. We've got 1.8 meters for the man. He is looking at an angle of elevation. So it's from his eyesight, from his horizontal upwards is 75 degrees to that plane. So we can see we've created a right triangle here that I'm highlighting in purple. This right triangle does not touch the ground. So if I'm trying to find how high the plane is off the ground, I could find this side length X of the right triangle, but then I need to also include that 1.8 meters to work out the total altitude of the plane. The important part here is the man is, the horizontal distance is 1200 meters, which we've got in our diagram. So looking from the man, we want to find the opposite side and we know the adjacent side of 1200 meters. So the tan of 75 degrees is X over 1200. So X is going to be 1200 times the tan of 75 degrees. So that gives us X as 4,478.46. So now we need to work out the altitude of the plane is going to be that distance X plus 1.8 meters. So it's a total of 4,480.26 meters high above the ground.